And when we're working with triple integrals, or even double integrals for that matter, the order of integration is very important. It really does not matter which way you set up the order of integration, as long as you follow that same setup throughout the evaluation of the triple integral. And since I already have my regions bounded here, x, y, and then z, that's going to be my order of integration. So I'm first going to integrate with respect to x, then y, then z. So this expression here can be rewritten as this. That's just the same integrand here with the bounds. This is the function 8x, y, z. And first I'm going to integrate with respect to x, so dx, then respect to y, dy, and then respect to z, dz. Again, this part here, the order in which you integrate, it can be dy, dz, dx, or dz, dx, dy. It really doesn't matter, especially when we're working with cubes or rectangular boxes. But as we work with more complex shapes such as paraboloids or other abstract figures, the order of integration may be important because it'll be easier to integrate in one way than another. But since we're working with a box here, it doesn't matter. So I'm going to be integrating with respect to x, then y, then z. And so we're going to integrate this here. So we first start with the inside, and we treat all other variables except x as a constant function, as a constant. And so if we integrate this, we get so it'll be x squared and then over 2, so that cancels out to 4. So that'll be 4x squared y z from 2 to 3, and then dy dz. And now we do top minus bottom here. So we plug in 3 for x. So that's 4 times 9, so that's 36. Minus, we plug in 2 for x. 2 times 2 is 4, times 4 is 16. And then y, z. Should be 36, y, z. dy, dz, and then the rest of the integrals here. So 1. So we can simplify this to 0 to 1, 2. So this will be 20 yz dy dz. And so we do the same thing here now with respect to y. And so if we integrate this, that'll be, just erase all this up here. Bring this up here. We integrate this, that'll be 20 y squared over 2. So that's just 10. And then z from 1 to 2, and then with respect to z. And so that can be written as 1, 10 y squared z, 2 to 1 dz. And so using the fundamental theorem of calculus, you're plugging 2 and then subtract that by plugging in 1 for y. So that'll be from 0 to 1. 2 squared is 4 times 10 is 40z minus 10z dz. And so that can be, again, simplified to integral of 0 to 1, 30z dz. And we do it again, finally, with respect to z. And so we take the integral of this, is z squared over 2, that's 15. can be rewritten as, oops, no, I'm gonna go here. 15z squared from 0 to 1. Again, we use fundamental theorem of calculus, and that'll just be 15 minus 0, which is 15. And so that's our final volume of the rectangular box here. So that is how you evaluate the triple integral.